So a while ago, I made a video where I tried to repair this, the Amstrad ALT-286. And in that video, we didn't quite get to the resolution that I had in mind. Now, I want to say thank you to those that reached out with some helpful ideas on what could be wrong with this machine. You guys had some great solutions and I really did appreciate them. The problem is none of them actually worked, but don't worry, all is not lost. I hope that looked good. I've got no idea what editing that's going to do. So yes, I've gone ahead and created myself an awesome little retro sleeper using this amazing Amstrad laptop. And why wouldn't you? The design of this thing just screams 80s cyberdeck. Now, I know some of you will have strong views on this. There are those out there that believe that retro hardware such as this should be cherished and you shouldn't be taking a hacksaw, or in this case a Dremel, to it. And I would agree with you if it weren't for a quick eBay search showing that there are loads of these still available in working order. So I see no harm in trying to do something special with this one. Of course, you can feel free to disagree with me in the comments, and I'll see you down there. Before we continue, I want to let you know that this video is sponsored by PCBWay. I use PCBWay for all my PCB needs, and the service I've received has always been quick, cheap, and of a high quality. Simply upload your Gerber files and select the options that suit you, and PCBWay will give you an instant quote. They also have a fantastic project library, many of which include a bill of materials so that, if you want to, PCBWay can source the parts to construct a PCB for you. What's more, the project owners are paid a commission each time you order their design, so it's a great way to support independent creators. Order yours today at PCBWay.com. So at the end of the last video, this machine was in quite a sorry state. I'd loosely put it all back together and then tossed it in a box in the garage, and yeah, apparently I didn't bother to screw anything back together. I cleared out the bottom part of the chassis of the old system board and drive cages, but then I needed to switch my attention to the top part of the chassis. You see, in deciding what to do with this machine, there were two questions I needed to answer first. Could I get a working screen in here? And could I get the keyboard to interface with a modern PC? So let's answer each of those in turn. For the screen, the existing panel is a monochrome VGA one, and as we covered in the last video, it would appear to be dead, or at least the circuitry that powers the backlights is. But we do have some options for replacing it. The original screen aperture is just over 10.5 inches diagonally, and it's a 4:3 aspect ratio hole. So I went on the lookout for something that could work with this kind of space. Initially, I thought about repurposing an iPad screen. Specifically, the iPad 3 and 4 had a Retina display resolution of 2048 by 1536, which is exactly double the pixel density of a standard XGA or 1024 by 768 display. And they're around 9.7 inches in size, so not that much smaller than the original screen. Certain models of iPad are really easy to repurpose, as you can find controller boards on places like eBay and AliExpress. But that slightly smaller screen size wasn't an attractive prospect for me, as it would have added even more bezel to the already healthy complement the machine has. I really would like to have used an iPad Pro screen, as certain models had a 10.5 inch diagonal, and these would have fitted this machine perfectly. But sadly, it seems that controller boards for these specific models just aren't being made at the moment. So I had a look around elsewhere, and after a bit of research on Amazon, I found an LCD panel which will fit our aperture more or less perfectly, and comes with a controller board which allows us to send an HDMI signal to it. Perfect! You can see here that this screen will fit beautifully in the bezel, maybe with just some grey or black tape to hide that shiny steel rim. And some initial testing connected to my laptop showed that it looks good enough for some 4:3 aspect ratio gaming at 1024 by 768. So now I need to work out how to mount it inside the monitor housing on the Amstrad. Thankfully, space wasn't likely to be a problem, as the original screen was much thicker given that it had fluorescent tubes as a backlight. So really, all I need to do is work out how to connect the screen's mounting holes to the mounting positions inside the chassis. The easiest thing to do is to put together a couple of 3D printed brackets. So to begin with, I overlaid the screen on top of the existing one to give me the position, and I began to map out what parts I would need to design to have it sit in the right position. When measuring up, and assuming the mounting holes on the original screen and the new one are both symmetrical, it turned out I was only about 1 millimetre out on the horizontal axis and more or less bang on the vertical. Score 1 for eyeballing it. So the next step was to take my hand-scribbled measurements, trust me, it makes sense to me, and knock up a couple of brackets in Tinkercad. After a bit of prototyping, okay, a lot of prototyping, I managed to come up with a design that held the screen in the right place, give or take, and had all of the mounting holes in the right position. Initially, I thought this would be easy as the mounting holes in the case were mirrored precisely, but yeah, not so much on the screen itself, so I had to modify the right-hand bracket and make sure it was clear on the model which was which. And the moment of truth with the screen bezel clipped in? Actually, that's not bad at all. There is a little bit of silver bezel showing, but it's uniform on all sides, so I don't think I'm actually going to bother painting this. I'll just leave it as it is. So the next thing I needed to look at was where the controller board for the LCD was going to live. Initially, I thought I was onto a winner as the board was almost exactly the same dimensions as the original screen's board. But because this one needs an HDMI cable to be connected to the bottom, there just wasn't quite enough room to squeeze it in. Plan B was to mount it behind the LCD itself. But when I measured, there just wasn't quite enough clearance to put it there with the necessary insulation between the board and both the screen housing and the back of the screen itself. So Plan C then, a 3D printed bracket which, unlike the screen mounts, I was able to knock out in one go, and then that can be positioned on the underside of the lower part of the housing. Before I went forward here though, I needed to make sure that the cables would all reach, and more to the point that they'd fit through the small aperture to the display housing section of the case. It took the removal of the status LED PCB and a little bit of a wiggle, but both cables were able to fit through, and so long as I keep the PCB as near to the aperture as possible, we should be okay for cable length. The best way I could think of securing the PCB bracket here was with some epoxy, so I mixed them up and applied it to the base of the bracket and then left that overnight to cure. So with the screen done, next I needed to look at whether the keyboard could be made to work with a modern PC. And to do that, I needed to look at how the current one worked. Referring back to the service manual for the original machine, it looks like the signalling for this keyboard is the same as a standard AT keyboard. We have 5V and ground pins, along with a clock pin and a data pin. You can ignore these other two connectors here for now, those are for the reset switch on the top of the case, but we'll come back to those a little later on. What's cool about the keyboard is that the AT standard remained in play even when we moved to PS2 devices. It was the same signalling, just in a different form factor. So in theory, I can solder on a PS2 connector and this keyboard will work with any device that uses a PS2 keyboard. So I stuck some DuPont cables into the keyboard connector, then twisted on the leads from an old keyboard and plugged it into one of those USB to PS2 adapter cables. And yeah, plugged it into my laptop, that works just great. So I disconnected the original keyboard cables from their connector one at a time and soldered them onto my PS2 flylead properly. And now we should be able to just connect this keyboard up to whatever PC we put inside here and it'll work just fine. So with those two major problems resolved, we're now down to looking at what machine we're going to put inside here. And to do that properly, we need to take a good hard look at the case and see what space we have to play with. My initial thought was to install a mini ITX motherboard, represented here by a piece of paper the same footprint. At first glance, it actually looks like it might just be doable, especially seeing as we'd have all the space over here for a Flex ATX power supply. But the problem is that a number of the holes in the case are for screws which thread through the base and then into the upper part of the chassis. And in particular, this one here is designed to have this steel bracket from the upper half of the case bolted onto it to support the weight of the screen. So we can't just not connect that without risk of the display sagging or relying on the strength of the plastics to put up with the hefty screen mechanism. In addition to this, even if we could just about squeeze in an ATX motherboard, we'd be drastically limited in height by the hinge mechanism for the screen. And even with an ultra-low profile cooler, I'm just not sure it would work. So I had a rethink, and instead of a full ITX-based PC, which would have been awesome, I decided to look at mini PCs, which are a whole different kind of awesome. I took a few measurements from manufacturers' websites and knocked up this 3D print model to see if this plan had legs. And although it will happily fit in the space we have available, the height presents a little bit of a challenge. It's looking like the best option will be to look at the other side of the case where the original battery and expansion bays were. If we can take the battery apart and preserve its casing, then we should be able to remove the internal plastics here, and then we'll have the maximum vertical space available. So, time to break out the Dremel, ooh, some lint, and get down to business. Oh, much better. We've got loads of space to play with now, and it looks like we've got enough space over where the battery and expansion section used to be to install a mini PC. So it's probably time to actually talk about that part of the build. For this build, Minis Forum kindly sent this PC to me for me to use in the build, and to give my honest thoughts on it as I do. I'm not sure they appreciated that I'll be doing this with it, but forgiveness is easier than permission, so let's go. So this is the Minis Forum UM890 Pro, a mini PC based on the AMD Ryzen 9 8945HS laptop APU, which includes their Radeon 780M integrated graphics. That's the same graphics core that's in my Asus ROG Ally, so we should be able to get some reasonable performance here. The CPU side of things has 8 physical cores with 16 logical threads, 16 megabytes of cache, and a max turbo speed of 5.2 GHz. That's phenomenal performance in a laptop CPU. I mean, the last time I built a gaming PC, which admittedly was 4 years ago, I invested in the AMD Ryzen 9 5900X, and Passmark reckons this laptop CPU has about 75% of the performance of that flagship desktop CPU from just 4 years ago. That's insane! On the GPU side, we've got 12 compute units running at a boost speed of up to 2700 MHz. I've been super impressed with AMD's latest iGPUs. And when you look at comparative benchmarks for this model, it becomes obvious that we're really entering a new era of iGPUs. I mean, this thing is chomping at the heels of a GTX 1650, and that's what you can still call a budget GPU at time of recording this video. And it only draws 15 watts, and it can do ray tracing. Okay, whether you want it to or not is another story, but it can do it. So before I bastardize this machine too much, let's take a look at it in a little bit more detail. To the front, you've got your power button, 2 USB 3.2 Type A ports, a USB 4 port, a combined headphone and microphone port, and a pinhole CMOS reset button. Round to the back, you've got another 2 USB 3.2 Type A ports, another USB 4 port, HDMI 2.1, DisplayPort 1.4, an Oculink port which is utilised via one of the 2 internal M.2 slots, dual 2.5 gigabit per second network ports, and a barrel jack for the included 19-volt power supply. That is an obscene amount of I/O for a device this small. And although realistically we're only going to be connecting 1 or 2 displays, you can connect up to 4 if you utilise the 2 USB 4 ports as well. Now, initially I thought I might get this into the laptop as is, but even with as much of the material in the case carved out as I can, it's still just about catching on the hinge mechanism. So we're going to need to strip this machine down and hope that gives us enough space. The magnetic lid just pops off of the case, and then we have the Wi-Fi and Bluetooth antennas, along with the cooling solution for the RAM and SSDs. There's just 4 screws here holding the heatsink and fan down onto the rest of the system, so we'll go ahead and remove those and... hold please. Okay, so there we go. It was just those 4 screws, but the stickiness of those thermal pads for the SSDs meant that it was held on rather snugly. Inside you can see we've got a Kingston 1TB NVMe SSD, and we've got 32GB of crucial DDR5 RAM. You'll note also that we have a second M.2 slot here. That can be used to add a second SSD, or you can add this Oculink adapter card to give you that Oculink connection out the back. I'm not sure I'll be using that in this build, mostly because I don't think they make Oculink extension cables that would allow us to add a connector to the Amstrad chassis. It looks like to be able to completely remove the heatsink, we'll need to remove the Wi-Fi card, and that's in a third M.2 slot nestled underneath the primary SSD, so we'll whip that out and then remove the Wi-Fi and Bluetooth card. Next, we need to see if we can get the rest of the machine free of the case so that we can see if that will fit in the Amstrad. And it looks like there's just 4 screws holding it in, so we'll whip those out and... it doesn't seem to want to budge. Hold again, please. Okay, so that was actually relatively easy. I just needed to remove the little bits of RF shielding foam and tape that had been added around the board, and with those out, there was just enough wiggle room to get the whole system board out. And it's actually significantly smaller than the case would indicate. This might just work. So, moment of truth. With the innards of the mini PC in more or less the right spot, will the top half of the chassis fit? Okay, we're on to a winner. Now, for added bonus points, will it fit if we had the cooling solution back on top? Ooh, interesting. We're onto one here. So there is one slight problem here, and that's that the cooling solution screwed into some mounting holes in the case itself. So now that we've removed it from the case, there's nothing for them to attach to. So I went ahead and knocked up a little bracket in Tinkercad that should allow the cooler to screw back on. Rather than relying on screwing into the PLA for this, I went ahead and used some threaded inserts. It took a few goes while I was prototyping to get these working right. They used the heat from a soldering iron to melt into the plastic, and then once they cool down and the plastic solidifies, they're in theory a stronger connection than just screwing into the plastic itself. And I should be able to screw in and out multiple times without the joint failing. So with that done, we have a solution that should allow us to install and remove the mini PC at will. Let's see if it all fits and will allow us to screw the case back together. Well, it does fit, but there is a slight problem. It's hard to show on camera, but the mounting bracket that supports the weight of the screen is blocking out these 2 USB ports, which is not ideal. But given that we've removed so much bulk from the machine, it actually now fits in the other way around. And this way, we still get access to all of the ports we need, front and back. That's a huge relief. But there's a few things we need to do before we install the PC permanently. First, we need to glue down the mounting bracket with some epoxy. Before I did this though, I added a little shim over on one side where the base of the battery compartment was lower. This was just so the PC was sitting completely flat while in use. I also worked out the placement of the cooling fan for the APU, and then drilled through the bottom of the case so that enough cool air could be drawn into it. Jesus, Matt, you nearly f***ed it there, didn't you? To stop anything jamming into the PC's fan, I also printed out a fan cover for the underside. Hopefully this will give the PC enough airflow to keep that APU cool. And with the PC slotted into its mount, we're one step closer to getting this build finished. Right, so with the PC installed, I now need to look at other bits and pieces that need to be installed inside the case. Of course, we're going to need the PC's power supply, but seeing as it's a relatively small unit, that shouldn't present us with a problem. I also need to include a second power supply for the screen, and I've gone with this 12V 5A unit from AliExpress. I'm not sure I would truly trust it to supply a stable 5A, but as the screen only draws 2A, I think we've got more than enough headroom. I also have to find a home for the cooling fan, a pair of speakers that will connect to the display's controller board, a power jack, and as many port adapters and extension leads as you can shake a stick at. Oh, and our USB keyboard adapter. Right, let's crack on. Well, that's a big relief. The machine still powers on and boots into Windows, and that display looks absolutely fantastic. The keyboard is also working just great, and I managed to sneak in a dongle for this wireless mouse, which pairs really nicely with the aesthetic. Well, considering this is a 35-year-old laptop. So what else is left to do? Well, although I've added 2 USB-C ports and a headset jack on the back where the original expansion slot was, I would kind of like to do something with the original D-type connectors that were on the machine. I managed to salvage the original mounting plate from the Amstrad's mainboard, but rather than just bolt in some blanks and call it a day, what if we could actually use them? Okay, I'm quite proud of myself with this one. Let's go over some of what's connected here. The original laptop had 2 serial ports and a parallel port. That's a total of 43 pins that we can make use of. So I looked at what connectors we had use of on the mini PC and how we might be able to utilize them via these connectors. For the 2 network ports, I wired a couple of cables over to the 25-pin parallel connector, and then I went ahead and created a dongle that converted back to 2 Ethernet ports. With the cables inside the laptop connected to the mini PC's Ethernet ports, I can then just use couplers to connect dongles onward to my network, and I do actually get gigabit speeds, which is awesome. For the USB ports, again, I soldered the wires from a couple of extension leads onto a 9-pin connector, and then created a dongle to convert back. I have throttled myself down to USB 2 speeds by doing this because the extension cables I used are only rated for USB 2. But to be honest, if I need to use anything faster, I'll just use the USB-C ports. And for the other 9-pin connector, I took the PS2 mouse port from the adapter that connects to the keyboard and mapped this over using a PS2 extension cable, with another dongle on the outside to connect any PS2 mouse. I know I could have just used straight extension cables and not bothered with using the D-type connectors, but I wanted to pay homage to those legacy connections, and it allowed me to leave the outward look of the machine relatively unchanged. The last thing I did was to hook up a power switch to the push button on the mini PC so I could power it on independently. You'll recall the keyboard controller board on the Amstrad also housed the original reset button, and there were an extra 2 wires on the keyboard cable for this to connect to the Amstrad's system board. So I buzzed out the power switch on the mini PC and worked out which 2 contacts were shorted when the button was pushed, and then soldered on some fly leads which I then connected to the Amstrad's original reset switch. And with that, we have a build that's in my mind, 100% finished. So how does it perform? Well, at the 1024x768 resolution of the screen, a lot of recent games are actually surprisingly playable. Doom Eternal on low settings plays well enough to spend some quality time doing so. And even Cyberpunk 2077 plays reasonably well on the lowest settings, returning playable frame rates if you leverage things like FSR and FrameGen. Which, to be honest, is all Greek to me, but it does seem to make a difference. Now, I could use this as a modern gaming machine if I wanted, but where this machine really comes to shine is with the Exodus project. I won't dwell too much on that here because there are already some fantastic videos which cover it in depth, but I've basically got any DOS game I could ever ask for at my fingertips, or at least the ones I have original versions of, and on a machine that feels like it would have been used back in the early 90s. I know some people will have some negative views on using emulation, but look, I'm a busy guy. I love playing on old hardware. I've got a whole YouTube channel about it, but it's an absolute pain getting all of the games I loved as a child working on vintage hardware. With Exodus on this machine, all the hard work has been done for me, and I've got a reasonably original tactile sensation of using a vintage computer to play these older games. I'm super happy with how this has turned out. It's a shame I couldn't get the original machine working properly, but what I've ended up with will probably be my go-to machine for DOS gaming. It's quick, it's easy to use, but it has enough modern features like Wi-Fi and USB to make it usable. In fact, I typed this script on it, and at no point did it give me any issues. The keyboard is actually surprisingly usable given that it's 35 years old, and has an Amstrad logo on it. If I were to do this project again, there's a few things I might have done differently. For a start, I wouldn't have secured down the PC mounting bracket with epoxy. If I'd created some mounting holes in the case, like I did with the power supplies, then I could have made the bracket removable in the future case of ever wanting to upgrade the mini PC. I suppose I could still do that in future if I chipped this bracket off, but I would have saved myself a headache by just doing it that way to start with. I also would have made more extensive use of the heatset inserts for some of the brackets. To be honest, I was a little bit afraid to try these, but they worked so well with the PC bracket that I probably should go back at some point and redo the screen brackets to use them as well. That said though, I'm still really happy with how this has worked out. It's a quirky machine, and it's given me a great chance to hone my skill in CAD software, and create something no one else has, to my knowledge, ever done with the Amstrad ALT-286. I hope you've enjoyed watching this video. I've certainly enjoyed making it. If you have, there's a button explicitly for that, and if you want to see more of this sort of content from me, I'd also like it if you consider subscribing. I'll also give you a quick shout out to the Retro Hardware Discord server, where you can converse with hundreds of like-minded people, myself included, via the link in the description. And finally, take care, and I'll see you again soon. Bye bye.